Right, in this video I will talk about variables. Or random variables, to be more precise. There are two kinds of variables in statistics. One is called the qualitative variables, right? So, for example, color. Color is a qualitative variable because you can take like red, blue, etc. Gender is a qualitative variable because it can be on male or female. Or pass, fail is a qualitative variable, right? And the second type of variables is quantitative. Quantitative variables. And quantitative variables are something like you can measure physically. Right? It can be like numbers, like 1, 2, 3, or it can be height, weight, etc. And there are two kinds of quantitative variables. One is discrete variables. So examples could be number of accidents, or number of earthquakes, right? Or you can also have continuous variables. So examples could be like height, or weight, or speed, and so on. These are all continuous variables, right? So there are two kinds of quantitative variables, discrete and continuous. And you also have qualitative variables, right? Right. Now, in this course, I will mostly focus on quantitative variables, right? Okay. So let me say what they are. So quantitative variables I'm going to use the notation. I'm sure you know this from probability 1. The notation I shall use is X, right? This is the notation I shall use to denote quantitative random variable, right? So now I'm sure you know this. If X is a random variable, then sorry, let me if x is a, I should have said discrete. If x is a discrete random variable, right, then the following notation, little p of x, defined as the probability that capital X is equal to little x, denotes what is known as the probability mass function, or PMF. All right. Now, on the other hand, if x is a continuous random variable, then I shall use this notation, little f of x, to denote is defined as the following. This denotes what is known as the probability density function. PDF, right? So the probability density function is for a continuous random variable, and the probability mass function is for a discrete random variable, right? And if you have a random variable, whether it's discrete or continuous, then the following notation, capital F of x, defined as the probability that capital X less than or equal to little x, right, denotes what is known as the cumulative distribution function, or CDF. Right. All right. So this applies for any kind of random variable, whether it's discrete or continuous. Right. Okay, guys. The next thing I'm going to talk about, some other notation, right? Now, if x is any random variable, discrete or continuous, right? this notation here, I'm sure all of you know what this means, denotes what is known as the population mean, right? Right. It's also known as the expectation. Right. Okay. So this is the population mean or the expectation, right? And if the variable is discrete, right, then you can work this out like this, right, over all x. That is, if x is a discrete random variable, and if the variable is a continuous random variable, then you integrate like this. So if x is a continuous random variable, right? So that's the first thing I want you to know. So that's the first thing. The second thing I would like you to know is the variance. The variance of any discrete or continuous variable is defined as this, right? Okay, right? So it can also be written as follows. Okay, and this is, in words, this is known as the population variance, right? And if you want to know the formulas for the two different cases, discrete or continuous, they are like this. So for the discrete case, if the variable is discrete, then this is the formula. If x is discrete, okay, and if the variable is continuous, okay, so these are the two definitions depending on whether you have a discrete or continuous variable. The next thing I would like you to know is SD. SD stands for standard deviation, and is defined as the positive square root of the variance of x. And in words, it's known as the population standard deviation. Okay. And let me go to the next page. The final thing I would like you to know is the expectation of x over n, where n can be any number. N can be 1, 2, or 3, or in 100, 1,000, right? And this is known as the nth population mean, right? And is defined as follows for the two cases. So in the discrete case, that's if x is a discrete random variable, okay, right? And in the continuous case is defined as the integral Now let me do a couple of examples. Example 1, I'm going to example 1. Suppose the variable x has the Bernoulli distribution with parameter p. You probably remember this distribution from probability 1, which you did last semester. So if you don't remember this, I will write it down, what it means. So a variable says, a variable has the Bernoulli distribution if it takes two values, 1 or 0, 1 with probability p, and 0 with probability 1 minus p. Okay. Now let's try to work out the things I mentioned in the last couple of slides. All right. The first thing is the expectation of x. The expectation of x is simply 1 times p times 0 times 1 minus p, which is, of course, p, right? The second thing is the variance. The variance of x, I'm going to use the following formula. So this will be, the expectation of x squared is going to be 1 squared times p plus 0 squared times 1 minus p minus p squared. So this would be p times 1 minus p. Alright. The next thing we talked about was the standard deviation. So that's simply the square root of the variance. Okay. And the next thing we talked about is the nth population mean, which is this, and this will be right, and this is equal to p. All right, so this is a simple example on the 4 measures I mentioned in the previous slides. Okay. The second example, example 2. Suppose x has the uniform distribution on the interval from 0 to 1. You probably remember this. Again, if you don't remember what this is, I will write it down. The CDF for the uniform distribution is equal to 1, right? If x is between 0 and 1, and it's 0 otherwise. Okay. Alright, the first thing we want to find the expectation of x. So that will be the integral from 0 to 1 of x times 1 dx, which is this, and this is equal to half, right? Next is the variance of x. Once again, I'm going to use this formula. So this is the integral from 0 to 1 of x squared times 1 dx minus the square of this, which is a quarter. Right? Now if you integrate this, guys, you get x cubed by 3. Take the limits from 0 to 1 minus a quarter. So this is a third minus a quarter, and this is equal to 1 divided by 12. Okay? And the standard deviation is the square root of the variance, so it's 1 divided by the square root of 12. You can simplify this to 1 divided by 2 times the square root of 3. And finally, the expected value of n at the moment, or the nth population mean, is the integral from 0 to 1 of x to the power n. Okay? Now if you integrate this, yeah, and take the limits, you get 1 divided by n plus 1. Right, so this is the second example completed, and this also completes the video on variables. The next video will be on independent elements or independent random variables.